Concept 6, Density and Buoyancy. Welcome back. Density is described as a measurement of how much mass takes up a given space. It's measured in grams per milliliter, or it can be measured in grams per a certain volume. An object with high density has more mass in a space. So here we have an example of a baseball. We can see the particles are represented here, and they are closely packed in this circle, and then the second circle is a rubber ball. They have the same volume, and we can see, well, same area, I guess, because it's two-dimensional, and we can see that these particles are further apart with more spaces between them. Therefore, the rubber ball is going to be less dense. How do we calculate density? The formula for calculating density is equal to mass of an object in grams divided by the volume of an object, which is typically milliliters. Okay, here's an example for you. A block of aluminum weighs 40 grams and it takes up 15 centimeters cubed of space, which is also equivalent to milliliters. What is its density? So what we can do is we can grab our calculator and we can go 40 divided by 15, right? Mass divided by volume, and we get 2.666 or 2.6 repeating. Okay. Let's look at our second example. Example 2, a block of iron has a mass of 2 kilograms and takes up 6 centimeters cubed of space. What is its density? So let's go back. Again, density is typically in grams divided by milliliters or centimeters cubed. So we have 2 kilograms and kilograms, right? So 2 times 1,000. And we're going to divide it by 6, our volume, which gives us 333, and then the 3's are repeating. Okay, let's look at our next example. A beaker of water takes up 15 milliliters of space and has a mass of 50 grams. What is its density? Well, we're going to go grams divided by volume. 50 divided by 50 is 1. So we're going to have 1 gram per milliliter or 1 gram per centimeter cubed. Okay, so let's take a look at example 4. I'm going to annotate on a separate document for you guys. So example 4, you have 2 rocks. The smaller rock is 15 centimeters cubed and the larger rock is 22 centimeters cubed. The smaller rock has a mass of 60 grams and the larger one has a mass of 45 grams. Which rock has a greater density? Okay, so I'm going to pull this up for you guys and we're going to take a look at this. Okay, so here we go. Okay, so I'm going to go rock 1. So I'm just going to go, this is going to be A. And the first rock, or the smaller rock, is 15 centimeters cubed. So density, mass, and volume. Actually, let's maybe make it a little thicker, just to help out here. Okay, so this is A. So density is equal to mass divided by volume. We don't know our density. Do we know our mass? We do know our smaller rock, yes. There we go. Mass is equal to 60 grams. And our volume is 15 centimeters Okay, so let's figure this out. So density is going to be equal to 60 over 15. So density is equal to 60 grams over 15 centimeters cubed. Density is equal to, get your calculator if you need to. Here you go, 60 divided by 15, which is 4. So 4 grams per centimeter cubed. So this is the smaller rock. Okay, let's take a look at the larger rock. So our larger rock has a volume of 22 centimeters cubed. So same thing, large. Sorry, I'm freehanding this right now. So our larger one, density is equal to mass divided by volume. We don't know our density. We know our mass. Our mass of the larger one is 45 grams. And our volume is equal to 22 centimeters cubed. Density is equal to 45 grams over 22 centimeters cubed. Density is equal to, grab your calculator, 45 divided by 22, 2 point, oops, 2.05 grams per cm cubed. Okay, what was the question actually asking? Which rock has the greater density? Well, the larger value is going to be right here, 4 grams per centimeter cubed. Therefore, the smaller rock. Okay, let's go back. Okay, relative density. So two mixtures will form layers if they have different densities. So I've actually given you guys examples in Google Classroom with the marble experiment. And you can see that there are potentially different layers. You'll have like a water layer, you'll have an oil layer, you'll have like an isopropanol or rubbing alcohol layer, a dish soap layer, a syrup layer. The substance with the lower density will rise to the top, and the substance with the higher density will sink to the bottom. The density tower demo is on Google Classroom for you guys to take a look at. Right, there are some questions to guide your thinking and for you to potentially look at doing this at home or in the classroom if you have those supplies. Right, you can look at your honey, your rubbing alcohol, your salt water, your dish soap, and your water. You have the relative density of those. If you were to place these into a beaker, over time they will separate into their respective layers. And obviously the one with the highest density would go to the bottom, the one with the lowest density would rise to the top. Okay, so this should be the order: rubbing alcohol, soap, water, salt water, and honey. Okay, in a glass of water, place an ice cube. Does the ice cube float on top or sink to the bottom? Okay, most of you have an idea that the ice cube would float. Think back to concept 1 and explain why that happens using the particle model of matter. Okay, what's actually happening to the water molecules when they freeze? Okay, so here's your answer. And again, you have access to these notes online. Google Classroom, you guys have a density virtual lab that you can do to explore different densities, looking at different materials and the properties and how volume can affect density. Buoyancy, which is similar or related to density. We look at Archimedes' principle, right? There are two forces that act on an object in a fluid. So there's a buoyancy and a buoyant force. And buoyant force is the upward force exerted by a fluid on an object immersed in the fluid. So notice once again we use fluid and not liquid. You can have a buoyant force in a gas as well. Okay, a little bit of foreshadowing. Gravitational force is the downward force on the object, and this is the object's weight. Okay, so the downward force is the gravitational force, and the upward force, that is the buoyant force. Sinking and floating. An object floats if the buoyant force is equal to or greater than the weight or the gravitational force of the object. And an object that floats is buoyant. Therefore, the buoyant force is greater than the gravitational force or the weight. Okay, Archimedes' principle. There's a video for you guys on Google Classroom. Okay, buoyant force is equal to the weight of the displaced water. The volume of the displaced water is equal to the volume of the object immersed into it. Okay, so we're using this to calculate the volume of the displaced water. Okay, so feel free to take a look at that density lab that's posted for you guys. There's a video on Archimedes' principle and showing you how he came about to this realization and how he applied it moving forward. If you guys have any questions, feel free to let me know on Friday, and have a good evening.